Hello everyone, I'm Meiyi Ma from the University of Virginia. My research is at the intersection of cyber-physical systems, machine learning, and formal methods with application to the Internet of Things, including smart cities and healthcare. And specifically, I develop rigorous and robust AI for real-world CPS IoT by integrating formal methods and machine learning. And today, I'm very glad to present my work on formal logic enhanced deep learning for cyber-physical systems. And in this work, I integrated formal methods with deep learning to increase the robustness of deep learning prediction. So deep learning are broadly applied for sequential prediction for cyber-physical systems and support them to make decisions. For example, in smart cities, a safety management system predicts the traffic flow in the next few hours and allocates security resources. However, such sequential prediction models for complex CPS are not always robust, often subject to anomalies. So in our work, we found that the target sequence often follows specific model properties, such as reasonable range, resource constraint, variable, and temporal correlation, which, however, are not always followed by the predicted sequence. For example, the changing of population has a temporal correlation with the changing of traffic or event, or the predicted traffic flow should not exceed the road capacity. But deep learning models have no direct mechanisms to guarantee that the learned distribution satisfies these model properties. Therefore, in our work, we built a new temporal logic-based learning framework that enforces RNN predictions to satisfy its model properties. And it gets the deep learning process with auxiliary knowledge of model properties and produces a more robust model for improved future predictions. And it can be applied to general sequential deep learning models and also to different application scenarios. To briefly introduce the framework, STRNet is built with a teacher network and a student network. And the key is that in the teacher network, we create a STL trace generator to generate a trace that is closest to the trace predicted by the student network and also satisfy the formalized model properties. And then we define a logic-based loss function and train the network through back-propagation. So in the evaluation, we apply STRNet to LSTM model and also transformer model and evaluate it on synthesized data and large-scale real-world city data. And the results show that STRNet significantly increases the satisfaction of different types of model property and also improves the accuracy of prediction. So the insight from our work is that first, considering real-world properties and requirements is important for building deep learning models for complex systems. And also, rigorous approaches based on formal methods are very effective to improve deep learning models. Thank you very much for watching this talk. Please contact me if you have any questions or comments. I'll be very glad to have further discussions.